Before the lecture, ask AI this question. Explain how ChatGPT writes to a fifth grader using a story game. 1. You start a story once upon a time, then you predict what word comes next based on all the stories you've read. Then the next word and the next. You're not copying a story, and you're guessing good next words. How can guessing one word at a time create whole paragraphs? 2. If I ask ChatGPT the same question twice, why do I sometimes get different answers? 3. ChatGPT can follow instructions like write a poem or explain like I'm 5. GPT-2 couldn't do this well. What changed? Paste this into ChatGPT, Claude, or Gemini. Understanding these concepts will help you use AI tools more effectively. Here's the surprising truth. ChatGPT, Claude, and Gemini all work the same basic way as the GPT-2 you used in the story generator demo. They predict the next word, one word at a time. Let's look at how ChatGPT generates a response. If you type, "What is the capital of Kazakhstan?" ChatGPT predicts one word at a time. It starts with "the," then asks what comes next. It adds capital, then of, then Kazakhstan, then is, and finally Astana. Each word is a prediction based on your question, all the words generated so far, and everything the model learned during training. The key insight is that ChatGPT doesn't know the answer in the way a human does. It predicts what words would likely follow your question based on patterns in its training data. You might wonder, why do you get different answers each time? Remember the temperature dial from the story generator? ChatGPT uses the same concept. At each step, the model calculates probabilities for the next word. For the phrase, "the capital of Kazakhstan is," it might assign Astana a 65 pies probability, Nur Sultan a 25 pies probability, Almaty a 5 pies probability, and other words like located or a much lower scores. The model then samples from these probabilities. It usually picks Astana because it is the highest, but sometimes it picks others. Temperature controls this randomness. A low temperature like 0.1 means the model almost always picks the most likely word, making it safe, predictable, and repetitive. A high temperature like 0.9 means it might pick less likely words, making it creative and diverse, but sometimes wrong. ChatGPT typically uses a temperature around 0.7 to balance creativity and accuracy. Now let's look at the evolution from GPT-2 to ChatGPT. GPT-2 could predict next words, but it couldn't follow instructions well. 3 major breakthroughs changed everything. First was scale with GPT-3 in 2020. While GPT-2 had 124 million parameters, GPT-3 had 175 billion parameters. That is 1,400 times bigger. GPT-4 is estimated to have around 1.8 trillion parameters. Bigger models are simply better at understanding patterns and can do few-shot learning. The second breakthrough was instruction tuning in 2022. The problem was that GPT-3 would predict text, but didn't necessarily follow orders. The solution was to fine-tune it on instruction-response pairs. Developers showed it examples like summarize this article followed by a good summary, or write a poem about cats followed by a good poem. Now the model learns to actually follow instructions. The third breakthrough was RLHF, or reinforcement learning from human feedback. The problem was that a model might follow instructions but give answers that were harmful, wrong, or unhelpful. The solution was to have humans rate responses as good or bad. They would ask which response is more helpful or which response is safer, and train the model on that feedback. The model effectively learns human preferences. RLHF is why ChatGPT refuses harmful requests, admits mistakes, and tries to be helpful. It learned these behaviors directly from human feedback. Let's survey the modern LLM landscape in 2024 and 2025. First, we have closed source models, where you can't see the weights. These include GPT-4 and GPT-4o from OpenAI, which offer the most capable reasoning and multimodal features. Then there is Claude 3.5 Sonnet and Opus from Anthropic. known for strong coding skills and a focus on safety. And Google has Gemini 1.5 Pro and Flash, which boast a massive 1 million token context window and deep integration with Google services. On the other side, we have open source models that you can download and run yourself. Llama 3.1 from Meta comes in various sizes and is free for commercial use. Mistral and Mixtral from France are very efficient, using a mixture of experts architecture. Qwen 2.5 from Alibaba offers strong multilingual support, and Phi 3 from Microsoft is tiny but capable enough to run on phones. Why does the difference between open and closed matter? Closed source models like GPT-4 are the most capable, easy to use via API, and the company handles all safety and updates. However, you can't see how they work. They cost money for heavy use. You can't run them offline and you can't fine-tune them easily. Open source models like Llama are free to use, run on your own computer, allow full transparency, and offer no censorship. The downsides are that they are slightly less capable, require technical knowledge and hardware to run, and you are responsible for safety. For learning, use free tiers of closed models. For customization, use open models. We'll do this in topic 5. Modern LLMs also have amazing new features. Beyond text, we now have multimodal models. GPT-4o, Gemini, and Claude can process text, images, audio, and even video. The same model handles all these inputs. We also have longer context windows. GPT-2 could only read about 750 words. GPT-4 increased that to 100,000 words. Claude handles 150,000, and Gemini 1.5 can read a massive 750,000 words. This means models can now read entire books, code bases, and documents. Finally, there is tool use. Modern LLMs can search the web, run code, query databases, and call APIs. The model decides when to use a tool and how. Everything still builds on the same foundations you have learned. Word embeddings are still used to convert words to vectors. Transformers and attention are still the core architecture. Temperature is still used to control randomness. And instruction tuning and RLHF are just advanced forms of fine-tuning. The models just got bigger and trained on better data. This is especially relevant for Kazakhstan. Modern LLMs support over 100 languages, including Kazakh, Russian, and English. Gemini and GPT-4 handle Kazakh reasonably well, but for the best support, you would fine-tune on Kazakh data. This creates opportunities to fine-tune open models, build Kazakh-specific apps, and create data sets for underrepresented content. You could contribute to making AI better for Kazakhstan. Let's summarize the key takeaways. Modern LLMs like ChatGPT and Claude still use next word prediction just at a massive scale. 3 breakthroughs made them possible: scale, instruction tuning, and RLHF. Temperature controls randomness. Closed models are capable but limited in control, while open models are customizable but require technical skill. Modern features include multimodal inputs, massive context windows, and tool use. And crucially, the foundations you learned: embeddings, transformers, attention, power, all of these. Now let's check your understanding. Answer these questions. 1. At its core, how does ChatGPT generate text? 2. What does RLHF stand for? What does it do? 3. Name 1 closed source model and 1 open source model. 4. What's the advantage of open source models? 5. Gemini 1.5 can handle 1 million tokens. Why is this useful? In the next demo, you'll master advanced prompt engineering using Google's Gemini API. You'll learn techniques like few-shot prompting, chain of thought, and role prompting, skills that work with any modern LLM.